Hello and welcome. This is going to be our lecture video for March 10th through 11th. Let's go ahead and get started by just practicing converting some equations to slope-intercept form. I'll do 1, 2, and 3, and then I'll have you guys embed a question for number 4. All right, so when converting to slope-intercept form, I should know what slope-intercept form is. It's y equals mx plus b. I should notice y is by itself, it's always on the left, x is with a coefficient on the right, and the constant's at the very end. So the first focus is get the variables on the side that they're supposed to be on. So the y is already on the left, that's good, but the x is on the left as well. It needs to move to the right, and I do that using an inverse operation. I subtract x from both sides. Now I've got negative y equals negative x minus 6. Now I need to get rid of the coefficient on y. I need to just get rid of that negative, so I divide everything by negative 1. All right, and I get y equals x plus 6 after I simplify. All right, next one. Same general idea, move the x to the other side. I get negative 4y equals negative x plus 28. All right, then y is not supposed to have a coefficient, so I divide away that negative 4. I do it to every single term. And then how I simplify this is important. I have a y by itself, but now I've got negative x over negative 4. The negatives are going to cancel out. I'll have x over 4. And I'll actually write that out. And then 28 divided by negative 4 is going to be a negative 7. But then I'm going to keep going with the simplification because this doesn't quite look like mx. I can't clearly see a coefficient on x. So I leave a 1 behind on top and pull the x out in front. So this is now y equals 1/4 x minus 7. All right, number 3. X is on the wrong side, move it to the other side. I now have negative 5y equals negative 13x minus 35. Notice I'm always putting that x term in front of the constant like it is in y equals mx plus b. Divide everything by negative 5. And I get y equals 13 over 5x plus 7. Notice the negatives canceled out there, both the slope and the y-intercept. All right, and 4 is up to you. I'll embed a question here for you to solve that one. Our goal today is to be able to check an ordered pair to see if it is the solution to a system of equations. Why are we doing this? So we can check our work and answer multiple choice questions quickly and effectively. So we need to go back to a semester 1 topic and practice substituting values. Again, I'll do the first 3 and leave the last one for you on this. All right, so our expression on the first one is a times number, or a value in front of a set of parentheses is always times if we don't see anything, b plus b. We're going to use a equals 6 and b equals 3. So a is going to be replaced by the 6, and both of these b's will be replaced by 3. Everywhere we see a b becomes a 3. That's what this means. So now I've got the expression 6 times 3 plus 3. All right, simplify inside my parentheses first. 6 times 6, which equals 36. All right, next one, y plus 5z. This time we're going to use y equals 1 and z equals 4. So 1 plus 5 times 4. Sometimes I use parentheses when I substitute, sometimes I don't. Especially if we've got a coefficient, I like it so that I don't confuse this for 54. This still is 5 times 4. All right, in PEMDAS, I'm going to do that multiplication first and get 1 plus 20, and now I can finish the addition and get 21. All right, number 7, 2z plus y, z equals 6, y equals 4. Watch out for when they're out of order like that. So this now becomes 2 times 6 plus 4. Multiplication first, 12 plus 4 equals 16. Put a box around that. All right, and number 8 is up to you. All right, now we're going to practice checking to see if some ordered pair. some combination of an x and a y value is a solution to a system. So is x equals -2 and y equals 7 a solution to this system? We're going to find out by doing substitution. We're going to see if this makes both of these balance. So do these values make both equations balance? It's not enough to just make one of them balance, because if we picture a graph, you can be on one of the lines without being at the intersection point. All right, so let's copy down that top one with some space, and now substitute in x equals -2 and y equals 7, and we get -10 times -2 minus 7 times 7 equals -29. This here is going to become a 20 minus 49 equals -29, and -29 equals -29. This first one is true, but we got to check the second one. 20x plus 4y equals -12. I'm going to substitute in a -2 for x and a 7 for y, and simplify. We do our multiplication before the addition. So I get -40 plus 28 equals -12, and I get -12 equals -12. This is also true. So they're both true. So yes, and I'll write it as an ordered pair, -2 comma 7 is the solution. All right, we have two intersecting lines. It's only going to have one solution. These equations will look much more similar if they were parallel lines. They'd have to have the same slope when simplified, and that's just not going to happen here. So we know that's only one solution. All right. One more is x equals 11 and y equals -7 a solution to this system. Let's find out. I'm going to go straight to doing the substitution now that I've had some practice. Multiplication before the subtraction, get -110. Sorry. Minus, well, actually that'd be plus because it's a negative times a negative. 16 times 7 is 122, or 112. And we get 2 equals 2. That's true, but we're not done yet. We have to check the other one. 7 times 11 plus 8 times -7 equals 5. Here I've got 77 minus 56 equals 5. This one's not looking so good. That's a 21 equals 5, and that is a false statement. So no. It is on one of the lines, but it is not at the point of intersection, so it's not a solution. And no is our answer. All right, I'll embed a few more of those for you to try, but that's that for this lecture video. Have a good rest of your day.